Hello students, okay, today we will discuss UCM, Uniform Circular Motion. This is the most important section in the circular motion part for CET, Maharashtra State CET exam. There is definitely one question on the uniform circular motion. Okay, now we'll see what is the difference between this circular motion and uniform circular motion. Okay, what is the definition of the circular motion? The motion of the particle along circumference of circle is called as circular motion, and in case of UCM you have to just add four letters or four words. The motion of particle along circumference of circle with constant linear speed, with constant linear speed. Getting the definition? Okay, the motion of the particle along circumference of circle with constant linear speed is called as uniform circular motion. Okay, the examples of this uniform circular motion: the motion of hands of clock, motion of hands of clock, motion of electron around the nucleus, motion of electron around the nucleus, and motion of moon around the earth. These are the examples of uniform circular motion. Now we'll see the properties of uniform circular motion. There are 12 to 13 properties. They are not included in your books, but they are important for entrance point of view. Therefore, I am discussing these properties. First property: the linear speed is constant. Linear speed is constant. There is difference between, you have to remember, there is difference between speed and velocity. Speed is the magnitude of velocity. Speed is the magnitude of velocity. Linear speed is constant. As this linear speed is constant, this tangential acceleration is zero. Tangential acceleration is zero. Okay, here the linear speed is constant and tangential acceleration is zero. Third property: angular velocity. Angular velocity omega, it is again constant. Okay, it is again constant. Angular velocity is constant, therefore angular acceleration alpha is zero. Angular acceleration alpha is zero. Okay, as speed is constant, so for performing this number of rounds around the circle, the time period is constant. Time period constant, frequency constant, time period constant, therefore frequency constant. Okay, linear speed constant, tangential acceleration zero, angular velocity constant, angular acceleration zero, time period constant, frequency constant. Next is kinetic energy. This kinetic energy again constant. Important property, frequently asked question. Kinetic energy in UCM is always constant. Kinetic energy is constant. Most important, the work done in UCM is zero. This is the most important property. This is asked about 4 to 5 times in entrance exam. Work done in UCM is zero. Work done in UCM is zero because work, okay, here is small proof. Work, it is given by F bar dot S bar. It is the dot product of force and displacement. If you expand this, you will get Fs cos theta. Here, in case of circular motion, the force required, it is the centripetal force. Okay, and displacement is in the direction of velocity. Displacement is in the direction of velocity. Therefore, angle is 90 degree. Theta here 90 degree and cos 90 is zero. Therefore, work done is zero. Work in UCM is zero. This is the 8th property. Okay, up to 8 property. Here are 6 properties are constant and 2 properties are 5 properties are constant and 3 are zero. Tangential acceleration zero, angular acceleration zero, and work done is zero. Then again, in this chapter you will later you will study the angular momentum. This angular momentum is also constant. Angular momentum is constant. Angular momentum is constant. Okay, for 10 number property, this 10th property, velocity, it is about the velocity. Velocity is changing. Velocity is changing. Why velocity is changing? Because velocity is tangential. Suppose a particle is at A, then velocity, particle is rotating in anti-clockwise direction, velocity will be in this direction. Suppose particle moves from A to B, particle moves from A to B, then velocity will be in this direction, so velocity is changing. The magnitude of velocity remains constant, but direction is changing, therefore velocity is changing. Okay, velocity is changing because direction is changing. Velocity is changing because direction is changing. Okay, then similar to velocity, then comes linear momentum. Linear momentum, it is changing because velocity is changing. Linear momentum is changing because velocity is changing. The formula for linear momentum, P equal to m into v. This velocity is changing, therefore linear momentum is changing. Then next property, the angle between radius vector, angle between this radius vector and velocity, angle between radius vector and velocity, this angle theta, it is 90 degree. It is 90 degree. And last and important property, this UCM is an accelerated motion. UCM is an accelerated motion. In 11th you have studied inertial frame of reference and non-inertial frame of reference. This accelerated motion occurs in non-inertial frame of reference. Non-inertial frame of reference. So this UCM is in accelerated motion. UCM is an accelerated motion and it occurs in the non-inertial frame of reference. These are the important properties. Again, I will repeat all the properties. Okay, I will separate all properties. First I will take constant. 6 properties are constant. First, speed is constant, then angular velocity is constant, time period is constant, then frequency is constant, kinetic energy is constant, and angular momentum. Constant are 6 properties. Which are these properties? Linear speed, angular velocity, then time period, frequency, kinetic energy, and angular momentum. 3 properties have 0 value. Okay, these properties, first property is work done in UCM is 0. This is most important. Work done is 0, work is 0. Then tangential acceleration is 0 and angular acceleration is 0. Okay, small proof for this work equal to 0. 2 properties are changing. One property, velocity is changing. Velocity is changing because this direction is changing. Linear momentum is changing because velocity is changing. Then 2 different properties, angle between radius vector and velocity is 90 degree. Angle between radius vector and velocity is 90 degree. Then UCM is accelerated motion. UCM is accelerated motion and it occurs in the non-inertial frame of reference. Okay. You have to remember these properties for problem also, because when problem is asked on hands of the clock and they have asked to find tangential acceleration or angular acceleration, you have to directly know the value of these two is 0. Okay, these are the properties. Now we'll see the difference between these two, uniform circular motion and non-uniform circular motion. Difference between uniform circular motion and non-uniform circular motion. I will write points on only one side. Okay, in UCM, the magnitude of speed, magnitude of linear speed, it is constant. Okay, so on the right hand side, non-uniform circular motion, you can write magnitude of linear speed is changing. Magnitude of linear speed is changing. Okay, this speed, it is caused due to change in this centripetal or radial acceleration. So I will write here centripetal or magnitude of, okay, magnitude of centripetal or radial acceleration is constant, and here on the right hand side the magnitude of this centripetal or radial acceleration is changing. Okay, the example of this uniform circular motion is the circular motion in horizontal plane. Circular motion in the horizontal plane. An example of this non-uniform circular motion, it is the circular motion in the vertical plane. Circular motion in the vertical plane. These are the 3 points of difference for uniform circular motion and non-uniform circular motion. Magnitude of speed is constant. Here magnitude of speed is changing. Centripetal, magnitude of centripetal or radial acceleration is constant. It is changing. This circular motion occurs in the horizontal plane and this occurs in the vertical plane. Example is the giant wheel. Okay, you all have experienced the giant wheel. This becomes non-uniform motion because of acceleration due to gravity. We will study it in the later half of the chapter. Okay, thanks.